Hello, everyone, and thank you for joining. We're going to wait about 30 seconds before we get started to give everyone an opportunity to push that button. All right, thank you everyone for joining today. Welcome to today's webinar. For our final best practices webinar of 2024, we have a special offering for you today with our panel of Azima subject matter experts. I'll let our moderator, Lee Morgan, make the introductions, but before we get started, I have a few housekeeping items to go over. If you lose audio or visuals, simply exit GoToWebinar and rejoin, and that should reset your connection. There's a chat feature available in your GoToWebinar menu panel and should only be used for general comments or for any technical assistance you may need. You have a question section also in your GoToWebinar menu panel. That's where you want to put any questions you have for our panel today so that they will see your questions and we'll be able to address those as we work through today's event. The presentation is being recorded and will be available on our Fluke YouTube channel within the next few business days. Lee, over to you so we can get started.
Great stuff. Thank you very much, Robin. So hello, good morning, good afternoon, and good evening, depending where you are in the world. It's my great pleasure to host today's best practice webinar, which is featuring 3 of our renowned industry experts in the world of vibration monitoring. Okay, so let me introduce our panel. So first up, we have Michael DeMaria, who is Director of Azima DLI Product Management. His role involves managing the hardware platforms and integrations, diagnostic software, plus AI tools. He's also got the user portal deliverables and business metrics as part of his key role activities. Michael's background is in Navy nuclear engineering, but has been working in vibration for over 30 years. He's been managing key accounts, technical support, customer training, and of course, product management for Azima DLI since 1995. We also have Steve Hudson, who is Director of Professional Services, thank you, Stephen, here at Fluke Reliability, again with over 30 years of vibration analysis expertise. He's also had roles in business development, product and service delivery, and his primary focus is on efficiency and promoting internal collaboration for consistent results, client partnerships, and brand quality. And last but by no means least, we have Austin Anderson, who is the product owner for Azima DLI's condition monitoring solution, with the focus of delivering customer value through AI, automation strategies, and initiatives. Austin has both a bachelor's and master's degree in mechanical engineering from the University of Idaho and is a licensed professional engineer. He joined Azima in 2022 with a strong background in vibration and acoustic focused research and development for the US Navy, specifically focusing on undersea combat systems and their failure modes. Okay, so you've met our panel for the day, and please remember, any questions, please drop them into the chat. Michael, I'm going to start with you, if that's okay. So sure. Let's pretend that I've literally just landed on planet Earth. I know nothing about who Fluke Reliability are, even less about Azima DLI. So how would you introduce them both? What do they bring to enrich our customers' daily workflows?
So from landing on the planet, that's it's going to take us a little while. I think an hour today for a webinar. You've never heard of Azima DLI before, or Fluke. So Fluke is a well-known in the industry to build tools and products to keep people safe. A lot of our customers really understand, how to use generally Fluke tools. There's a brand that goes behind Fluke that people really kind of trust. The motto of John Fluke has been, customers deserve a little bit more than what they pay for. And we certainly follow those kind of traditions. Where Azima DLI fits in is Azima DLI has been around since 1966. We've been well known in the industry for automation and vibration analysis. We've had large services contracts where we manage vibration programs for huge enterprise customers. But we built products to collect vibration data from very advanced online systems to simplified tools for technicians and operators that still capture high quality data to do analysis to wireless sensors that you can put upon machines. But what sets Azima DLI apart is the automation and the services that we do. Especially true today, where data is expected to deliver really, really high results, and you need to have a lot of planning to understand what you need to do, how soon you need to respond to it. Machines are becoming a lot more technical. Plants are becoming a lot more lean, and we fit in there very, very, very nicely in providing those types of diagnostics that customers really kind of need to understand the risk within a plant. Not just knowing that a machine is, you know, green, yellow, or red, and that it's about to fail, but really specifically what needs to be done to repair the machine. Very plain language action with a huge priority. If you step back to Fluke Reliability, Fluke Reliability has three unique branches to it. It's the starting point of it we'll call Pruftechnik. Pruftechnik has a very well-known hardware brand. They make very quality products in alignment, in vibration, and the like. And they are our hardware arm of being able to capture the high quality data that we're talking about. Then the next step would be us. We are the software and services. So now that we have data that's being captured, the Azima software is highly capable in being able to diagnose all that data that's coming in and producing the repair action recommendation. And we couple that with a huge services arm. So customers who need to get through volumes of data, need to get more out of their data, need to be able to handle all the different types of ways that machines can fail. Our services department is able to provide those types of expertise, as well as up-leveling something very technical to the higher up in the organization, plant managers and above, who need to understand really the risk to production, not necessarily the technical fault on a machine. And finally, the third arm of Fluke Reliability is eMaint. So now that we've identified that there's a problem on a machine, how do we execute upon a work order to resolve that problem and bring back the kind of metrics that management really needs for understanding, am I compliant in my program? What are my bad actors, my worst offenders? How proactive am I? What are the faults and the like? So we are, just to summarize, Fluke Reliability is the combination of Pruftechnik hardware, eMaint execution, and us in the middle, Azima DLI as software and services.
Okay, well that was a 5-minute crash course into who Fluke Reliability are, so thank you very much for that. So it sounds like Azima is a critical portfolio or critical part of the Fluke Reliability portfolio. What do you see are the key accomplishments, if I can say it right, that you guys have achieved in 2024 so far?
So we joined Fluke Reliability in August of 2023. So it's been just a little over a year. And in that time, there's been a tremendous amount of development that's been done to really kind of first understand what are our customers' needs under Fluke Reliability. Again, how does what is a Pruftechnik customer need? What is an eMaint customer need? How is our Azima DLI customers going to benefit from the fact that we're now part of Fluke Reliability? So there's a lot of integration that we've done. We've already brought in some of the Pruftechnik hardware. The biggest pain point that we saw at the beginning was customers with online systems, the VidGuard hardware that's capturing tons of data, but plants really don't know how to handle that volume. So we built an integration to be able to handle the software and services that we talked about, the automation on that platform. We've expanded upon our wireless portfolio over 2024. We've integrated a bigger customer success teams to make sure our customers are being cared for like they're expecting. Same for our services and our support departments. There's a lot that we've done that was able to leverage kind of the strong arms that Fluke Reliability and Fluke has to offer in order to really kind of make our customers benefit from the capabilities that we're able to deliver. We have built a huge, better connected solution that's able to drive a lot more market in the wireless platform and being able to provide a lot more diagnostics and capabilities, and has really kind of grown the volume. So over the course of 2024, there's been tremendous amount of growth in what we've done for data that's coming in. And just to kind of pass this over to Stephen, there's been, if we started out looking at the beginning of 2024 into the presentations for the audience here that's been kind of joining along in the best practices webinars, and you've seen Azima DLI, you would probably have noticed that the kind of the numbers that we've presented of how many machine tests that we do, how much data we're responsible for, has grown over the years. And I think it'd be kind of interesting to know, Stephen, where we've landed now from the beginning of the year to the end of the year and the amount of data that we're handling from services.
Yeah, thank you. And to clarify, this is the numbers, the metric that we track is basically the total number of test outputs that we relate to customers. And we've had something like 6% growth in the machines, but we went from 560,000 tests at the beginning of 2024 to now we're going to have almost 900,000 tests here at the end of 2024. So that's the total aggregate tests that we have in that year. And the year before it was only 331. And I just want to state that that's primarily a growth due to the changing landscape of the type of data we get. Rather than somebody doing walk around data and collecting data once a month, we're getting at least 30 times more of that kind of data, but now coming from wireless sensors and online systems.
So did you possibly think it was going to grow exponentially? Because I mean, that's a big jump, right? 300,000 to 900,000 in less than 24 months.
We did, but it is catching a lot of people by surprise. We've been on probably an 8 or 9 year path, kind of getting ready for this, knowing that we were getting into wireless, knowing that it would really change the landscape of how we collect data. I think we'll talk a little bit about the data explosion and what that means for people. But we had to kind of change the way we used our tools. Very thankful that we had a big customer to partner with on this and really get in front of it. But it has been an explosion, triple what we just had a couple of years ago, with only, I think, a total of 8% more machines and programs. But again, the data type is changing, and this data overload is really coming after people. But we've done, I think our team has done exceedingly well at trying to handle this kind of excess data, and that's what we're trying to again teach other people at the same time. We certainly have a couple of stories about customers that got overwhelmed by the same kind of thing. So
what if we were to jump 2 years ahead? Where do you see it going? What do you think we're going to be at in 2 years' time, for example?
Well, I don't want to overestimate, but we are prepared. We know it's going to hit 1 million, 2 million, and then possibly 4 million. So I think 2 years from now, we'll be at least somewhere between 2 and 4 million test results in a year from these same kind of machine tests, just getting so much more of it and trying to be responsive to every test every day.
And if I understand it right, the more tests we do and have in our library, basically the more predictive we can actually get moving forward.
That's correct. It scales very well, and we have an enormous data lake going back many years. We use that data. We do leverage that data to help us set baselines and help us learn more about particular machine types, and that in turn helps the customer get better insights. I think that's really one of the key things. So, we had a customer, for example, 1,600 machines, a refinery, and on their own, not related to us, they moved from traditional walk around to wireless. They saw an increase from 19,000 tests a year handled by a group of their own analysts to over 500,000 tests just for that site alone. So we came in kind of what Michael's talking about there, where we've learned to integrate either our own VipGuard or even other wireless platform data and be able to apply our diagnostic system and our methodology to those so that they get proper insights, because more data doesn't mean better insights. In fact, it kind of means the opposite. And that's what people need to be prepared for when they think they can handle, maybe they have a team of 2 analysts and they're handling things just fine. Well, now increase your data by 30 times and see how well that works for you. And that's exactly what they were up against, is they went backwards essentially. So being able to help bring that, because we know that roughly 20% of machines are moderate or above type of faults at any one time. And if, you can just do the numbers on that. What we really need to focus our analysts on is that 3 to 5% that is actually in serious or extreme faults that need action this week, this month. That's where we have to focus the actual analysts to give those additional insights. So having an automated system that helps us focus where the analyst needs to be focused has really been the path that we've taken. When I say we've been working on this for 8 years, trying to really get our analysts focused on what really needs our attention. As a matter of fact, then the insights, the persistence, the fact that the same fault will persist day after day as it progresses, and making sure you can track that fault through.
Yeah, no, understood. And I'm probably going to bring Austin into this conversation actually, because I think the more data you have, people's resources are finite, right? A human can only do so much during the day. So Austin, what about any advancements in technology that have helped us support this sort of huge scale in data?
Yeah, absolutely, Lee. So I'll just step back and give a brief review of kind of how the system sort of works on a high level to the audience who may not know. But our hardware, it's out in the field, whether that's to walk around a portable system or wireless systems, which are growing more common. But all that data it streams ultimately back to a centralized cloud location. And so as always, computers are at the heart of everything that we rely on to do a lot of this heavy lifting for us. And with modern advances in cloud architecture and technologies, this data it's much easier to get from some remote African mine all the way to in the hands of our team of skilled analysts. And so that's a huge enabler. And then our diagnostic system, which has been alluded to by Stephen, that's been shaped ultimately over many years. It wasn't developed. It's been continually improved upon and shaped to accommodate more machine types, different failure modes. But it works in a highly automated fashion where this data comes in, and we've already sort of defined a somewhat strict data format of we want certain ranges of frequencies in our Fourier transforms and our waveforms and those kinds of things. But our diagnostic system is able to ingest this data and very quickly spit out a diagnostic result, which is then picked up by Stephen's team of highly skilled analysts and sort of massage and shape these and do some further analysis to make sure that the customer is getting the clearest picture they can of what's happening on their asset. And ultimately, this, with the advent of wireless sensors, this data comes in day after day. So it's a data tsunami, I think, as Stephen likes to say sometimes. But this automation system, it really helps you segregate very quickly what needs to be looked at and what is less of a priority. And so it does this very quickly, and it really helps increase the level of automation that we can provide.
So you mentioned, oh, sorry, yeah, sorry, Stephen. So you mentioned there about AI does some of the lifting, the expertise, the human expertise. Is there like a hard, fast rule? When do you guys decide, is it AI doing it or is it a human expert doing it?
There's I'll get this started, Stephen, and then you can take it over. So pretty much all results of ours are going to be initially evaluated by our AI diagnostic system, and it provides that initial screen. And as a result of that, so you think about, as an example, the output being we'll take all this data and we'll output sort of a priority on that of how bad we think that this machine's condition is based on this data set. And in addition to that, it also takes into some recent context of what's been happening recently on this machine. You know, how has this trended over time? And from then we can make some pretty educated decisions on whether that needs to be handed off for additional enhanced review by a human, or whether we can say we're comfortable delivering that result to the customer as it sits by the automated system, because we're that confident that we've established a pattern of trends and faults, and therefore it doesn't need to be looked at by a human. It may have already been recently looked at by a human. But Stephen, I'll let you add some color to that too, because I know in practice you guys, you know, it's more complicated than that. But
it is, and you know, everything we do is based upon a machine template. We build these templates. We call it an MID. We build these templates on the onset of a program, and we build what some may term as a baseline. What we use for a baseline is a statistical average. That's an average spectrum. So we compare the incoming data. Again, we're doing spectrum analysis. We're not just looking at overalls or anything like that. So that is key to our program, and our methodology is to have a really comprehensive statistical average. We do use a standard deviation for all the lines of the spectrum of that average. And so, one, we've got to understand the machine. We build the template. You know, we understand that it's a motor coupling pump, and the diagnostic system understands that. And so we do have a refining period up front where we have to ensure that we have that template built correctly. That's really the key to this, is making sure that that template is matching the machine. And then we've got to make sure that we're getting the right data, that our ranges are set correctly and all that. So, and then finally, we begin building that statistical average. We can pull the starting point for that. We can get it two ways. One, we have an algorithm that lets us build a synthetic baseline from day one. So we have insights right up front. Also, we can pull from that data lake we talked about, that massive amount of data. We can find a like or an identical machine in that database and use that as well as a starting point. But from there, we use actual machine data of that particular running machine or that group of machines and build that statistical average. And that's what makes this this diagnostic system so strong, because that's that screening. So that's really just keeping in mind that there is that initial period where we're refining it. And, you know, we find with wireless sensors that happens pretty quickly. It takes weeks, whereas in the past it used to take months or sometimes years if we couldn't get good repeated data on a machine. So that is key to that. So, and you know, Michael, you might have some to add to there as well.
Well, I think it's about the time to delivering. So it's about, I think the big line between humans and the AI is a tool for the humans. And it's about that whole process that you talked about, set up a new, let's say we put wireless sensors on a machine. And a wireless sensor is very autonomous. It has to understand, you know, if the machine is running, is it running in the right conditions? Is it the right criteria of data that we need to understand the faults of the machine? Where does it look in the data to find those faults of the machine? Things like, you know, how many motor rotor bars are there, how many pump vanes, how many fan blades, what is the running speed? Machines are complicated. Analysis of that data is even more complicated. So if you think back 10, 20 years, it took, as you said, mentioned, Stephen, it takes quite a bit of time in order to get enough good data sets for even a human analyst to do manual analysis, to be able to say, I'm able to understand what is normal for this machine and pick out the outliers that could generate a fault. And our system does all of that in a very autonomous way, identifies what are the patterns, how does spectrum or waveform relate across the entire machine train, how does it all come together to generate, this is the logical fault and this is the logical repair of a machine. So the AI system that we have, the automated diagnostic engine, tries to bring all of that faster to a customer. How do we become way more efficient, higher utilization rate of an analyst to say, hey, we have a massive amount of data over decades of capturing it. that we should be able to cluster and identify, hey, logically, this is where motor bar rate is. We can now identify all the faults that could be related electrically within a machine. And so getting that result out faster. And in a wireless world where you're capturing data so often, we should be able to get something that is quickly turned around in place. The customer could be not blind to what's going on while they're transitioning from, say, going from walk around to an installed system. It's time to deliver is the line between the two.
Yeah, okay. And something to add there, because I don't know that I fully answered your question. Initially, when we take on a program, the human analyst is looking at 100% of that data during most of that refining period, and that's what we try and get away from as quickly as we can. We want the automation to take those faults that are either not those machines that are not a problem, or they have an emerging fault, just an early fault that just is being noted, and pass that result straight to the customer, and then escalate only those things that really need the analyst attention. That's really key to this path, we think.
Yeah, makes sense. Makes perfect sense. So we've spoken a bit about AI, and obviously AI means a lot to different people. But how? I mean, I think Michael probably is the best person to answer this as product manager. How does the human versus AI sort of story align with where Fluke Reliability are going, for example? So without giving too much away about the roadmap, how does that sort of, how do those two work hand in hand?
I think one of the things that we didn't mention in all of the context that we did before about the analysis that we do, it's about the accuracy of the analysis that we have to provide. So it's not just, hey, we've identified that there's some probability of a problem, or you have something shaft related, or again, I just have a traffic light that says the machine is healthy or problematic. Our customers expect that we're able to deliver a very highly accurate prioritized repair action recommendation at the component level. So data comes in, we want to automate as much as possible. Every set of data that comes in should be able to be analyzed and delivered back to a customer with a high level of accuracy. So where our AI is going always focuses on how do we do this faster, more efficient, and more accurate. So a fault that comes in and somebody's going to respond upon that, they have to be able to trust that that system is giving them the right recommendation. Nothing worse than taking down a multi-million-dollar machine to find out that you have the wrong call that was made on it. And we can't do that. We have to have a highly accurate, our services team is on the hook to make sure that they deliver that. So where AI goes is basically, like I said, is tooling for the human analyst to have things in their toolbox to be able to deliver the accuracy of it. Where we're going, I think Stephen summed it up great. 900,000 machine tests, right? But what was the increase? 300,000 and 900,000?
Yeah.
Over the course of 2 years.
2 years.
And I have seen those projections. Brought up 4 million. That's what we see as kind of in that future of what we're going to have to handle. So and it's not just that's just, I think, factoring in the vibration data from sensors, but there's more data that's going to be coming as we develop more and more technology to be able to understand machines. It's just going to be more data to be able to deliver more condition-based maintenance, not just vibration. So AI, the direction of AI is to really understand how to manage that at scale, how to get more information and insights, how to deliver that in a way a customer can maybe query it in different ways that they find necessary. They've talked about the data lake quite a bit. If you think about the data lake, it is tagged information. So it's just not data. That 900,000 machine tests, I think we did the math on this not long ago. It was like 263 million data points that comes from that data. It's a lot of data points. So there's no way a human can get through that and try to make out anything meaningful out of it. I think it was just not long ago, there was a paper that was written about how much data we've captured and how much people use the data. It's usually after the fact, something happened, now let's go back and see if we can learn from it. but we want to be proactive about it. So how can we take this data that we have, all these data points that are coming in, and do something that is really more meaningful? I think that's the direction of AI. Being able to enable analysts as a tool. It's not a job displacer. You know, it's basically a technology in your toolbox.
Yeah, completely agree. I probably got a question about how customers perceive this. So I think maybe of the three of you, I think Stephen probably spends more time with customers than anybody. So, I mean, Stephen, in terms of our customers' needs and expectations and kind of their core drivers, what are the most important factors to them when they look at installing a solution like this?
They want meaningful insights. That's really what they're after, right? They are looking to have a risk assessment. You know, anytime they operate a plant, they want to understand the risk that they're operating that plant. They need to be able to make decisions based upon their schedule, what their deliverables are, and if they have a machine that is beginning to fail and they can plan that repair for a time when they're not in production, for example, that would be the preferable. So really what we see is that we partner with our customers to try and give them the best evaluation of risk from a vibration data standpoint as we can, right? And then we can roll in other technologies as well, because they have a lot of technologies in front of them. Some that they can again use our portal and our tools to display and track. But essentially oil analysis, thermography, right? There's other aspects here that do play in and that we do take in consideration. But the biggest thing I think they're after, right? They need to write a meaningful work order, get a guy out to a machine to do a meaningful repair, and not waste time on machines that don't need attention, and really focus on those machines that are presenting that risk. So, you know, it's all around, you know, risk assessment.
Understand. That's what, keeping with the customer flow. I mean, I know, Austin, you also spend quite a fair bit of time with customers. What's the big pain points they say? You know, what keeps them awake at night? What do you see from a lot of the customer visits that you undertake?
I think it's a sort of pivot off of what Stephen was saying, is translating the output of, you know, a condition monitoring, you know, program, and how does that translate into action and the appropriate timing of that action. And to be honest, it's a significant challenge because, you know, identification of a fault can occur in various stages depending on where it is in that PF curve, you know, when we identify it. And so there may be, and every machine is different. And so the time from identification of a fault and watching it progress over time, it still yields, you know, an uncertain sort of future of if you let that machine go, if the user doesn't do any action, when will that fail and how will it fail? You know, what other damages is it going to cause along the way? And I think that's really, you know, it's probably what keeps our customers up at night. It certainly keeps me up at night at times. It's like, how can we find a way to pinpoint to you when this is going to occur and when do you need to take action? Because as Stephen said, you know, you're managing a production, you know, it's, you know, you got output, you know, X amount of widgets, you know, whatever you're outputting. Yeah, that's got to be taken in context with, you know, your planned downtime, and then and certainly you don't want to have unplanned downtime. And then, you know, once you're able to make that decision that a work order needs to be generated, is how do we interface with the results from our system, which are, you know, fairly autonomous. Once you're part of our program and you've got our services team and our hardware involved, you know, there's a lot of data still coming at you. So even from the onset of identification of that, you know, we've identified some imbalance in a motor and an early stage bearing wear that's detected. You know, the user may decide to, you know, perform a work order or take action now, but in between them deciding to take that work order and them actually performing that maintenance action, there's, you know, we're still monitoring that fault. It's going to progress, and we need to find that balance of giving that user additional context of, you know, how is this progressing, and then from a technology standpoint is how do we interface to your system? So, you know, CMMS, our solution is not a CMMS solution, the Azima solution, but, you know, every customer does implement, you know, their work orders typically in a CMMS program of sorts, such as eMaint, which is our, in our Fluke reliability portfolio here. And where we'd like to go with this is to make sure that we integrate in with those systems to give you, the quickest path to a work order and understanding context of what's happening on your machine. I think that's kind of what our customers are asking for, and certainly something that we're trying to work to provide for them.
Okay, makes sense. Now you mentioned something about a PF curve. Now imagine I've just landed on planet Earth. I don't know anything about anything else. Can you tell me what is a PF curve, please? I mean, I need education.
Steven,
do you guys want me to take that? So a PF curve is a pretty famous curve in the maintenance industry, and it's generally understood that the functionality of a machine, it just basically draws an arc from high output, high reliability to zero output, zero reliability, in other words, machine failure. So it's a pretty simple curve, but the concept here is that we would like to find or perceive a fault as early as possible along that curve, so that the customer gets that timely action item to go and do that repair. So again, PF curve is basically perception to failure, is the idea of a PF curve. So, how early you can perceive it. Some faults, you can have some faults that are really going to have almost no effect for years. Imbalance, I won't say imbalance doesn't cause damage, but it's not generally considered an urgent fault, whereas a bearing, a roller element bearing that's failing might fail in weeks or more pretty quickly. And then we also have some that are catastrophic failures that go from perception to failure in a matter of hours. So there's a whole myriad of fault types, and you're trying to track that with multiple platforms, with multiple technologies. And that's how we generally apply the PF curve. It's just, we are the function of perceiving that as early as possible on that curve and communicating that with the customer reliably.
Right. Okay, that's great. Thank you very much for that description and explanation. So Michael, as a product manager, so listening to what Austin and Stephen just said, how does that translate to what we should be looking for in terms of the roadmap or solutions that maybe soon approaching?
Oh, they should have brought this up much sooner than so we can get this. No, I'm kidding. No, that's exactly what we've seen. I think Stephen's definition of the PF curve, and you just landing on the planet, Lee, kind of really builds upon what it is that we're trying to solve for customers. It is very, very technical and hard to do. Vibration analysis is not, it's not an exact science. It's not straightforward. You can certainly dumb down that technology. You can go to we would call them just a hand raiser. I have a single threshold limit that crosses over and it says, yeah, my machine has a problem. It's super easy to handle, but that doesn't give you any kind of meaningful insights. So knowing that there's a very technical thing that needs to be addressed is a problem that our customers really kind of face. We are still in a world where there's large amounts of skill constraints that customers have, resource constraints. Being able to keep these technical experts on staff is harder and harder to do. So where we're driving this is, how do we enable customers to get that type of information that they need in the plant from these types of connected systems. So there's an expectation that customers have of being able to have all this data coming in. The customer, what Austin was talking about, these customers that have plants that are running 24/7, you certainly don't have all of your experts. If you even have experts, they're not there around the clock. One of the calls that we've had recently with a customer was very concerned about things that happened over the weekend. My plant is in operation. I have to have some sort of coverage. So how does our system know that machines are healthy, that something's not problematic, that I don't have to get my maintenance group up in the middle of the night on the weekend and come into the plant? Understanding what are the risks to production is big business within a plant. There's bottom lines that have to be met, and making sure the equipment is running in a its peak optimal state is not a primary focus that the maintenance department has the luxury of being able to do these days. In the 30 years ago, you had a lot of people in the plant, lot fewer machines that each individual was responsible for. And you had typically, maintenance downtimes. You had shift works that had the plant down, you repaired things, you kept them operational. Now we operate 24/7. So making sure that the equipment is able to keep up with that demand is not something that a plant is easily capable of doing. So our roadmap is all about how do we deliver these solutions at scale? How do we understand what's going on, being able to deliver results as fast as possible so I know what my risks are? How do we insert an analyst, their expertise at the right point to say, hey, this is something that needs your attention, make sure you respond. When we look at wireless devices, that is our future, that data is coming in very frequently. Like I said, in a very autonomous way. And if a typical plant only has maybe, 10% of the machines, 15% of the machines tops, hopefully, have significant problems. So how do we ensure we understand the risks of all that data that comes in and flag just the ones that you need an analyst's attention on? So our roadmap really is kind of focused on kind of that building better tools, a bigger bridge, integrating everything together. Austin talked about Azima doesn't have necessarily a work order system, but that's where eMaint comes in. Yeah. So on that scale, every day, wireless sensors capturing more data, an online system's capturing that pretty much just constantly. So I have new data that's come in, I have an action that's necessary, all of a sudden I have more data that's coming in. How do we handle that daily management of what I really need to do and get the understanding, the value out of it to make sure it's done correctly?
Yeah,
that's what
makes sense. Now then, I'm going to move, because we've been talking a lot about the wireless aspect. Now, you guys know I don't come from a vibration background, but I do come from a wireless comms background. And I know that wireless isn't always perfect and has its challenges. So it's a question to all three of you, and you can decide who leads the answers. But what advice would you give to somebody who is looking to, say, implement a wireless vibration monitoring system?
I'll take a first stab at this. I think what's important, sorry about that, is what's important is you really need to understand what it is that you want to get out of a wireless system. So we've talked about this as, you can be all over the place, from a simple hand raiser that says the machine is green, yellow, or red, or you have a portable system that you have less staff, you're operating more around the clock, and you need to have an on-par solution to what you can get out of a walk-around program with more advanced technology. Or you can be looking at a lower-cost solution to an online system, the more advanced capabilities. An online system used to be really just for the critical assets because of the cost, but wireless devices are catching up with the technical capabilities to be able to put that on more and more machines. But you're all over the map on this one. So I think the first thing that you really need to do if you're thinking about a wireless system is understand what it is that you really want to gain out of that platform. What's important to you in a plant that you're going to put this device on the machine. So what is it that you need out of that? If you're thinking, I just want a hand raise, I just want a traffic light, our approach is we went more than that. We want to be able to say, yes, it's red, but this is specifically why it's red. If that's not important to you, like I'm just going to throw away the machine and put another one on, there's probably cheaper devices that are out there. Yeah. If you have if you plan on repairing the machine, or you need, say, early detection, I need to know before it goes into red, I need to kind of know that it's trending, and I have plenty of time to plan for that. That's where kind of a different approach. That's where our sensor kind of comes in and shines. So I think that first step of what is it that I need is kind of where I take a first shot.
Yeah.
Okay.
And then I'll add to that it's, as we've already mentioned, the data overload, right? Michael said, I think it's 260 million data points this year. and that includes all the overalls and all the basically the process points that we have. If you break up the amount of spectral data we have, that's another almost 40 billion lines of data that's coming in right now per year. So this is, like I said, it's not as simple as just monitoring simple things. We actually have to take a very complex approach to be able to get those insights Michael mentioned, to be more specific about it. And again, that just kind of going back to that point, the data overload, people that are taking on a wireless program need to be prepared to either have a diagnostic system or take the approach of, we're gonna take a real simple overall level, and all we need to know is that the machine has some sort of problem and maybe it's a run to failure. But on those machines that are critical to your production and you can't afford to just replace them ad hoc, those are the ones that definitely need the more concise approach that a diagnostic system will give them.
Okay, great stuff. Austin, anything to add on my wireless question?
Yeah, I'll follow up just with understanding the environment that you're operating in. So, wireless devices have come, they're an incredible piece of technology, that's sort of arisen out of this modern computing era. But, at the end of the day, these sensors operate with basically microprocessors. They got soldered joints in them. There's like any sort of integrated circuit. And so you can't put these in a really high temperature area. It's just a fact, and I don't think unless you invent some sort of new material that you can, solder with that operates at high temperature. So, understanding what the nature is of what it is you're monitoring, some sort of hazardous areas with high temperatures, that might be more situated for an online system, which of course, Pruftechnik and Azima support as well, and that might be a better alternative. But and then sort of secondary to that is sort of the communication path. So those sensors, they're just sitting around. They communicate back to our cloud via a sort of advanced Bluetooth methodology. You need to make sure that you've got, wherever the layout is of your particular plant, you need to understand that there may be some dead zones here and there. So there's an approach that needs to be taken here that you need to figure out. That you need to find a way for this data to reliably communicate back to our cloud here and so for analysis. So we offer, of course, cellular and Wi-Fi options. Those are obviously the two best ways to get that data out of your plant. But that's a consideration that needs to be made too, or early on in the process as a customer when you're starting this program.
Yeah, I couldn't stress that enough, that if you are thinking about a program, the sooner that you can bring your IT department into that mix. Can't be soon enough and often. There's a lot of wireless devices that are on the market. So it's a very fair question because it could be hard to navigate if you're just thinking about getting into the wireless world. Certainly start looking at what are the features of the devices. Austin talked about how we communicate. So we use a mesh network to lower the cost of how many gateways. It's a kind of a consideration. How are the devices going to communicate? Think about the wireless device as a completely autonomous system, like what we talked about earlier, all the different things it has to try to figure out on its own. So is the device that you're looking at able to handle that type of automation? The battery life, how do you manage batteries? How does do I need a longer battery life? How do I manage the technology as it changes? Like I said, there's a lot of wireless devices that are out there and it's constantly changing. There's that technology is on that, we crossed the chasm. We now have massive amounts of technology that are capable in this space. And it's just advancing at an astronomical rate. Think of cell phones and tablets and like 10 years ago, how quickly we started seeing so many of them on the market that all had their own pros and cons to it. So again, back to that, what is it that you want to get out of the program? How do we manage the devices? How do we ensure that it's understanding the machines? What are we getting the results out of it? How do we handle things like the stability of data that's coming in to making sure that the machine's is buffered out before it starts making calls? Or once you have a call, how do we understand the persistence that we need to do something again and again and again, to Stephen's point on handling the volume of data? And then how do you get the confidence out of it, that when it does tell you something's wrong, that you can trust that it's the right action to take. So there's a lot of things to balance when you're thinking about the wireless world.
That makes sense. It makes sense. I think it's like anything before you jump, then preparation and planning is kind of important to get right in the first place. Now I am conscious of time because we're approaching the 10-minute barrier, and I really want to get to some of these audience questions. So thank you all for putting the questions in the chat and the ones who submitted before the event. So you guys can decide who are going to answer this. So the first audience question is, what's needed generally for automated accurate diagnostics? And what about the level of training required to produce good enough results? Who wants to get that? Is that more Stephen's question, I think?
Stephen, we all voted for you.
Yeah. Stephen's been voluntold. What do you think?
Well, what is generally needed, as I stated before, is more or less a good understanding of the machine, right? We have a lot of simple machines out there. Those are generally very easy to understand and set up a diagnostic system for. And then we have more complex machines. For the complex machines, we need to know more or less the shaft speed of every shaft inside of a gearbox when possible, right? If we go in blind, it's a lot more difficult to give you specific recommendations. So that's the key thing. And the other part of that is today we live in the world of variable frequency drives, right? Everything is variable speed. To the chagrin of every vibration analyst in the who 30 years ago everything was pretty well fixed speed and very easy to track. Today we have to track speed. So having a good way to monitor what that speed is, and we do that primarily today with an algorithm. We actually pull it out of the vibration data pretty accurately as long as we understand the machine. So again, during that initial period, we really have taken the approach of gathering as much machine information as we can up front and understanding that machine, because we know that getting to automation, that if we skip that step, we will either never get to automation or it'll take us a very long time to get there. So and again, that adds to the more accurate diagnosis. So the variable speed, the complexity of the machine, belt driven, gear driven, we need to know all the shaft speeds. So we're pretty good at finding that out with a site visit. Sometimes with small programs, we can do that with communicating with the customer with photographs and things like that. But that is key to the automation piece for us for sure. So we have a great implementation team that goes out and does this for customers. And prior to installing sensors, we need to understand that machine, or at least at the same time as we install sensors, right? That's the preferred methodology. So and then training, we do have customers that we sometimes will take that over, and maybe for 6 months we'll do that analysis, we'll train those templates, we'll do that baseline process, and then it certainly is plausible to turn it back over to an analyst team and then provide them with some level of training to use our user interfaces and our diagnostic system. But we have found that it is understanding that automation process is the most difficult part for any new customers or anybody that has an existing vibration team. But once it's up and going, their vibration team could take it over, for example.
Okay, that makes sense. Okay, now we've got a really interesting question here. So I don't know which one of you guys want to take this one. So describe the connection between condition monitoring to property loss risks from an insurance point of view. Anybody?
I'll take this. Oh, go ahead, Michael, if you've got it.
No, you're probably going to be better off at this. Let me just pick on the insurance one. We do have cases where we have plants that do need to do vibration analysis programs because of their insurance programs. Ships, for example.
That's what it is.
Most definitely have to have a program in place so they can ensure the safe operation of their vessels.
Okay.
I'm sure there's other cases. Go ahead, Stephen.
No, and I was going the same place. Essentially, where we have seen that and seen it for at least a decade or two is that the marine industry has certainly taken the approach of, to have a safe and reliable ship and insure that ship, they have to have a reliability program that is certified. So other industries, I don't want to say they haven't picked it up, but they've been much slower to start implementing that kind of program. But it certainly has been done. But again, we would really look to ABS or other organizations like that certify ships or marine industry for that kind of guidance. We have a team that is ABS certified, for example, to go out on these ships and do that kind of work.
Okay, that makes sense. We've got a pretty generic question. So tell us more about the use of vibration tools in industry. How do they benefit the typical reliability engineer?
Austin, you want to take this one?
Yeah, I can give it a shot here. So as an RE here, I would imagine it's really about visibility. So if you're an RE, you're probably like most REs on this planet. I imagine they've just got too many pieces of equipment to monitor at any one time. I mean, you can't spend an hour at each one and understand its state at all times. And so really, I guess our system is really tailor built for the RE to get a very clear and quick understanding of the state of your assets. And if you think about how much time is saved on, how much manual analysis that you need to do, and of course there's a wide range of vibration and vibration expertise when it comes to the reliability engineers. Some are more focused on, vibration than others, of course. And so, our system really caters to sort of both ends of them, really. If you're a reliability engineer and you like getting your hands dirty, then our system really, it's compatible with that sort of methodology too. So we'll prioritize the machines that need action and are resulting in sort of issues. And as a RE, that really pinpoints you on where you should focus as with your own vibration analysis expertise. And then of course on the other end of the spectrum, if you're a reliability engineer who's you're more focused on you're not necessarily a rotating machine expert. You're more focused on, I don't know, some sort of, boiler reliability or something like that. Our system really enables you to very quickly become, somewhat more educated on what's happening in your rotating machinery. So, on all ends of the spectrum, it's basically making your job easier, I think, from our system. But Stephen or Michael, if I'm missing any big thoughts, jump in there.
Yeah, let me add to that as a great point. The other thing I would say is that RE has to balance so many different things, too many different technologies together, and balance that with what I need to do. The platform supports online systems, wireless systems, portable systems, all going through the same technology stack. It also supports you be able to balance that with other types of technology, IR and the like, to say this is what really needs to be done on a machine. And I think the other thing that's really benefit here is what we deliver is not just, again, the fault of a machine, but how do we understand risks and other kind of key metrics. So KPIs, benchmark metrics, business level metrics. So the platform can really make the RE shine, being able to deliver upward within the organization what they're saving, what's the financial risk, what is the key saves, what does that relate to the ROI or bottom line. It's a tool that's just not about finding a fault in a plant, but taking that technical thing and making it under relatable in business sense, so that the plant can understand what the value they're getting from the RE's department in vibration analysis, especially.
Okay, I'll try and squeeze a couple more questions in because we've got quite a few in the chat, and there's a real great one actually about data reduction software. So the question reads, with the exponential increase in data transmission, have you explored any data reduction software? Nice question. Have we?
Yeah, go for it, Austin.
This is probably, we don't have enough time to really dive into this subject, but Stephen, I was going to talk about Impact DMOD as a data reduction sort of processing technique. We certainly do not have the time to, I would love to follow up with that customer, or Stephen can. But essentially, it's like, how can you capture a ton of data at once? And we have a processing technique where, we can sort of reduce this very large, long time waveform and essentially reduce it down to a reduced set of, only 2,048 samples basically. And that can tell you whether, your machine is impacting, whether you're in need of lubrication or those kinds of things. And it's really, our Impact DMOD technology is sort of for some faults is some of the earliest detection on that PF curve, like we mentioned. It's kind of the earliest way to detect some of these failures. But yeah, anyway.
That was good. It's exactly what I would have said. So yeah, we're compressing in that case, we're compressing up to 500,000 samples down to 2,000, just over 2,000 samples. So, so we definitely in the signal processing area, we have taken that approach for sure.
From the wireless perspective, Lee, if we're thinking about how much data is being transmitted from wireless devices through gateways into a cloud system, we do monitor this very highly. So understanding where the peaks are, how do we balance this thing out? How do we make sure that all the data is there's a handshake, that we know that it's come through, that it's all put together in a way that we can do diagnostics on the machine. So there is a tremendous amount of data that always moves nowadays. And there's tooling that has to happen in the back end to make sure that it's being handled correctly. So not necessarily reducing the amount of data, because we don't want to get rid of data. We want to be able to have everything usable. It's a matter, I think, from our perspective, it's more about making sure that we are getting what we're expected to get from the devices.
Yeah. Right. Okay. Okay, so I've just noticed we are at time, so I don't think we have enough time for any more questions, but what we will do, we've got your contact details. Everybody who's asked questions that we haven't been able to get around to and answer, we'll do that offline. And hopefully you've all enjoyed the event. Thank you very much to the 3 panelists, and thank you to everybody for giving up 1 hour of your valuable day. If you enjoyed the discussion today, you could get the chance to meet these 3 experts in person. So check out our event coming next March. It's in Austin, Texas. We'll send details out after the event. But basically, you'll get to meet all 3 in person at our Accelerate 2025 event if you wish to attend. So now I believe I'll pass you back on to our organizer, who will close the call.
Yes, thank you, Lee. Thank you, everyone, for joining. Many of you have been to many of our webinars this year, and we look forward to seeing you at next year's webinars. As a quick FYI, when you exit GoToWebinar, there will be a window that pops up with a very short 30-second survey. Take an opportunity to tell us what you think and what you'd like to hear about as we plan next year's schedule. Thank you, gentlemen, for your time today. To our audience, thank you all, and we'll see everyone next year.
Yeah.
Thank you.
Thank
Thank
you.
you, everyone. Thank you.